Welcome to the Health Headliner podcast by Tudu Digital. Our content is informational only and not medical advice. Please consult your provider. Now, let's dive into today's headlines.
Notice as you get older that your bones, well, they make themselves known a little more. You know what I mean?
Yeah, they announce their presence.
Yeah. And it turns out it's not just a feeling. The actual cells in our bones, the ones that give them strength and structure, they change too as we age. So what exactly happens inside these cells that can make our bones feel weaker as we get older?
Well, that's a question that some researchers at the University of Texas at Austin have been exploring. They worked with some folks at the Mayo Clinic and Cedars-Sinai Medical Center.
Okay.
And their findings, which they published in Aging Cell, offer some really new and insightful perspectives on age-related bone loss.
So this deep dive then is all about understanding the changes to our bone cells as we get older.
Right.
Thanks to this recent research. We want to figure out what those changes are, how they happen, and what they mean for conditions like osteoporosis. So think of this like a shortcut to understanding the key points of this complex topic.
Exactly. Now, at the center of the story are these super interesting cells called osteocytes. They're actually the most common type of cell in our bones. And, for a long time, they were thought to be pretty passive, just kind of hanging out in the bone. But now we know they're actually the main controllers of our bone health.
Main controllers, that sounds pretty important. So what do they do?
Well, they have a couple key functions. First, they're incredibly sensitive sensors that detect the mechanical forces acting on our bones. Like when you move, your bones experience stress, and these cells pick up on it.
So like little tiny stress sensors.
Exactly. And then, based on what they sense, they direct the process of bone remodeling, which is essentially the process of building up and breaking down bone tissue. They tell other bone cells when to build new bone and when to break down old or damaged bone. And that balance is crucial for keeping bones strong.
So like a constant construction crew in our bones.
Yeah, a really sophisticated one, though, because it's not just random building and breaking down. The osteocytes are in charge.
Got it. So they're in charge of bone maintenance and assessing what needs to be done and when.
Yeah, that's a great way to put it. Now, here's where the new research comes in. What they found is that as we age, these osteocytes can enter a state called cellular senescence.
Cellular senescence. We've talked about this before with other cell types. So what's it mean in this context?
Well, in simple terms, it's like a state of damage or stress. When a cell becomes senescent, it stops dividing.
Okay.
But here's the catch. Unlike cells that just die off and get cleared away, senescent cells, they hang around. They're not dividing, but they're not quiet either. They start releasing all sorts of molecules that can be harmful.
So they're like disgruntled retired workers causing trouble.
Kind of, yeah. And the study found that when osteocytes become senescent, they actually undergo some structural changes. The internal support framework of the cell, it's called the cytoskeleton, it starts to stiffen.
Right.
And they also saw changes in the outer membrane of the cell.
Okay, so stiffening, how bad can that be? One of the researchers on the study, Mariam Tilton, she had this really interesting analogy to explain it. Something about a building, right?
Yeah, she compared the cytoskeleton to the scaffolding you'd see inside a building under construction. Now, if that scaffolding is too rigid and can't adjust, the building becomes weaker, less able to deal with stress. It's kind of the same with osteocytes. When the cytoskeleton stiffens, the cell can't adapt to the stresses our bones experience every day.
So basically, it's like the scaffolding in a building that gets old and rusty and can't support the structure anymore.
Right, exactly. And if they can't adapt, they can't do their job of sensing those mechanical signals. And you remember, those signals are vital for healthy bone remodeling.
Right. So it's like the communication system of the bone breaks down.
Exactly. Now, it doesn't stop there. These senescent osteocytes, remember, they're releasing those potentially harmful molecules. Well, this is called the senescence-associated secretory phenotype, or SASP. It's kind of a mouthful.
Senescence-associated secretory phenotype, so SASP.
Got it. So what's in this? What did you call it? A cocktail? Yeah, it's like a toxic brew. It's got pro-inflammatory signaling molecules, enzymes that break down tissue, and other factors that cause damage and inflammation around the senescent cells.
So it's not enough that they're not doing their job. They're actually making things worse.
Yeah, they're really contributing to a negative environment within the bone. And what's really interesting about this study is how they identified these senescent cells in the first place.
Yeah.
Usually you look for specific genes or proteins that are markers of senescence, but those can vary depending on the type of cell. So this team took a different approach. They said, hey, if these senescent osteocytes are getting stiffer, why don't we just measure how stiff they are?
Okay, makes sense.
Yeah.
So how do you actually measure the stiffness of something so tiny?
They used a technique called optical fiber-based interferometry nanoindentation. It's basically a very precise way of poking a living cell with a tiny probe and measuring how much it
It's
deforms.
like a microscopic finger poke test.
Yeah, something like that. And it lets them measure exactly how stiff the cell is. Now, in their paper in Aging Cell, they laid out exactly how they did this.
Okay.
They took osteocytes from mice and grew them in dishes in the lab.
Mm-hmm.
Then they use radiation to make the cells senescent, like a fast forward on the aging process.
Got it.
Then they measured the stiffness of the cells at different time points, 7, 14, and 21 days after making them senescent. And of course, they had a control group of cells that weren't senescent for comparison.
Okay, so what'd they find? Did the cells actually get stiffer?
Yeah, that was the main finding. The senescent osteocytes got progressively stiffer over time. The longer they were senescent, the more rigid their cytoskeletons became. And they also saw those changes in the cell membrane we talked about.
And that's what messes up their ability to sense mechanical signals, right?
Exactly. They basically concluded that these biophysical changes, these changes in the physical properties of the cells, impair the osteocytes' ability to do their job. They called it impaired mechanosensation and mechanotransduction.
Lots of big words. But basically, the cells can't sense the mechanical signals and can't convert them into instructions for bone remodeling.
Right. Now, this is where things get really interesting.
Okay, so we're getting to the implications. Like, what does this mean for us?
Right. Think about conditions like osteoporosis or just the general bone loss we experience as we age. This research really points to impaired osteocyte function, caused by the senescence and stiffening, as a major reason why our bones get weaker and we're more prone to fractures as we get older.
So it's not just that we're building less bone as we age, it's that the bone cells we have are becoming dysfunctional.
Right, and that's an important distinction. But this also means we could develop new treatments for osteoporosis by targeting these senescent osteocytes.
Okay, so how do we fight back against these dysfunctional bone cells?
Well, there are some interesting ideas emerging. Miriam Tilton suggested that just like physical therapy can help with stiff joints, we might be able to use targeted exercises or other types of mechanical stimulation to actually reverse senescence in bone cells, or even help get rid of them altogether.
So moving our bodies could actually keep our bone cells younger.
That's the idea, and it's a promising area for more research.
Oh.
And then Dr. James Kirkland, he's an expert in aging, he talked about using these biomechanical markers like stiffness as targets for therapies that eliminate senescent cells. Instead of using drugs that target all senescent cells in the body, which can have side effects, we could specifically target the ones in bone.
So a much more precise approach.
Exactly. We could address the root cause of bone weakening without affecting other tissues.
Now, obviously, there are some limitations to this research, right? It's not all cut and dried.
Of course, you always have to consider limitations. One of the main ones here is that most of the work was done in vitro, meaning in the lab, in dishes. And that's not exactly the same as what's happening in a living bone. In the body, in vivo, osteocytes are embedded in a hard matrix and squeezed into tiny spaces.
Right, so it's a much more complex environment.
Yeah, so the results from the lab might not perfectly reflect what happens in a living organism. And another thing is that they used a specific type of cell line called MLOY4 cells in some of the studies.
Okay.
These are helpful for research, but they're not identical to the osteocytes you'd find in a living bone.
So the cells in the lab might not behave exactly the same way as the cells in our bodies.
Right. And then the way they induce senescence using radiation, that's another consideration.
Okay.
This type of senescence, it's called stress-induced premature senescence. It's a good model, but it's not exactly the same as what happens naturally over time as our cells divide and age, which is called replicative senescence.
So it's like they gave the cells a stressful experience to age them faster.
Yeah. But natural aging is a bit more complex. And one last point, even though they showed that senescent osteocytes become stiffer, they didn't directly test whether this makes them worse at sensing mechanical signals.
Right, so they didn't prove definitively that the stiffening directly causes the dysfunction.
Right, that's an area for future research.
Right, but they have a lot of evidence that suggests it's the case.
Right.
So we talked about different researchers' opinions. We've got Miriam Tilton, who's excited about the exercise and mechanical therapies.
Yeah, she's really enthusiastic about the potential of using movement to improve bone health at the cellular level.
Right. And James Kirkland, he's all about those biomechanical markers.
Yeah, he sees them as a very precise and potentially less invasive way to target senescent cells, which could be a game changer for treating age-related conditions.
And what about the authors of the Aging Cell paper? What's their take?
Well, they're big proponents of biomechanical stimulation. They believe that applying specific forces could actually help rejuvenate aging bone cells. So it's kind of a similar idea to Tilton's focus on physical therapy and exercise.
Right. Like we could potentially reverse some of those negative changes by stimulating the cells.
Right. And then there was another study, the one called Tracing Cellular Senescence in Bone. They found something really interesting about those SAP factors, the harmful molecules released by senescent cells.
Okay.
Turns out those SAP factors were much more harmful when they were right next to the osteocyte, in their immediate environment.
So the closer you are to the senescent cell, the worse it is.
Exactly. The local effects were more important than the distant effects.
Well, that's been a fascinating look into the hidden world of our bones and how they age. And I think it gives us a lot to think about, not just about bone health, but about aging in general.
Absolutely. I mean, who knew that our bones were so dynamic and responsive, even at a cellular level?
So the main takeaway here is that as we age, our bone cells undergo changes that can make them less effective at their job.
Right.
But the exciting part is that we're starting to understand those changes. And that opens up a whole new world of possibilities for keeping our bones healthy as we age.
And it highlights the importance of those lifestyle factors like exercise and diet that can influence bone health.
And this is all thanks to a deeper understanding of these tiny but powerful cells, the osteocytes.
The unsung heroes of our skeletal system.
So what do you think? Can understanding the way our bone cells age lead to personalized approaches for maintaining bone health?
It's a big question, but the research is moving in that direction.
If you're interested in learning more about this, there are tons of resources out there. You can look into cellular senescence, the science of osteoporosis, and a whole field called mechanobiology, which is all about how physical forces affect our cells.
There's so much to explore.
Well, thank you for joining us for this deep dive into the fascinating world of aging bones.
It's been a pleasure.
We'll be back soon with more deep dives into exciting new topics. And if there's anything you'd like us to cover, just let us know.
Until next time.
Take care.
Thanks for tuning in to the Health Headliner podcast by To Digital. Like and subscribe for more health news and breakthroughs. Stay healthy and informed. See you next time.